All right, so again, 4, 4 is what we're on, and we are going to complete the square, which will then force these equations into one of our conic, our standard equations for the conic. And then from there, if it's a parabola, you would plot your point, you would find your directrix, you would find your focus. If it's an ellipse, you'll find the center, you'll do the vertices, you'll do the foci, and then you'll draw your ellipse. And then if it's a hyperbola, you'll do your center, you'll do your vertices, you'll do your foci, you'll find your asymptotes, and you'll graph. So it's kind of a combination of all that. So quick review on complete the square because it's been a little while. So the first thing we're going to do is keep the AX and the BX terms on the left side of the equal sign. This time, there may be an AX and a BX, and then there might be an AY and a BY. So you might have 2 squared terms. Okay? If you only have 1 squared term, it's going to end up being a parabola. If you have 2 squared terms, then it could end up being an ellipse or a hyperbola. So if there's 2 squared terms, you're going to complete the square twice. Once for the x and once for the y. So you remember, you group them together, you find that third term, you add the third term inside the parentheses, and you're going to add it to the other side of the equal sign. If you took something off of the x squared or the y squared term, then you have to multiply it by that number first before you add it to the other side. Then, so that's at like step 3. Add the term to the left and to the right to balance the equation. Again, if something's factored out, we have to multiply it by the number on the front before you can add it to the right. Then you'll factor the perfect squared trinomial. Square root the first term, square root the last term, take the sign from the middle. So what will happen here is you'll end up, like I said, with either just an x squared term, and the y would be on the other side, and that would be a parabola, or 1y squared, and the x would be on the other side, and those would be parabolas. Or you'll end up with an x plus or minus a number squared plus y plus or minus a number squared, and that's going to be an ellipse. Or you'll end up with x plus or minus a number squared minus y plus or minus a number squared equals 1, or the reverse, y. And those would be hyperbolas. So remember, ellipses and hyperbolas have to be equal to 1. Parabolas do not. And then again, based on whatever conic it is, you would then know what you need to do. Do I need to find the vertex, the directrix, the focus if it's a parabola? Do I need to find the center, vertices, foci if it's an ellipse? Or do I need to find the center, vertices, and asymptotes if it's a hyperbola? All right, so we get here first, y squared minus 6y plus 3 equals x. So first of all, what's squared? Just one term, right? And it's the y. That tells me this is going to be a parabola. So immediately you either have just one term squared or you have an x and a y squared, okay? If it's just one term squared, I know it's going to be a parabola. So this is a parabola, okay? Which means at the end I'm going to find the vertex, the directrix, and the focus. So everything determines what you have to find, okay? So now the thing I want to do is I want to keep the squared term and the letter that matches it on the side by itself, but I want to move everything to the other side. So I'm going to keep the y squared here and the 6y. I'm going to leave that space for the thing I'm going to fill in because I have to make it a perfect square. But then I'm going to kick the 3 to the other side with the x. So this is going to say equals x minus 3. Now I'm going to fill in that space. So I'm going to take the y, or the number that's on the front of the y, which is the 6. I ignore the sign because we end up squaring it at the end. I'm going to take that 6. I'm going to divide it by 2, and I get 3. And then I'm going to square it, and I get 9. And that's what I'm going to add into this blank here. If there was something on the front, I'd then multiply it by that before I add it to the other side. But there was nothing taken out. So we just also add it to the right side. We got to balance the equation. So whatever I do to the left, I want to do to the right. Now the whole goal was to make that left side a perfect square trinomial so that we could now factor it, right? So I square root the first term, what's that y? I square root the 9, which is 3. I take the sign from the middle, that's a minus 6y, so it's minus. Put it in parentheses, square it, equals x plus 6. Everybody with me so far? So this is a parabola, yeah? What do we know about it? It's horizontal because it's y squared. Good. The vertex, yep, is negative 6. So technically this would be in parentheses if it was to look like what we normally get it to look like. The vertex would be negative 6, positive 3. We said it's horizontal. Does it point to the right or to the left? To the right because it's a positive 4p, right? Speaking of, what is 4p? 1. So there's a 1 here. 4p equals 1, which means p is 1/4. So I'm going to start with that information. Vertex, negative 6, positive 3. Plot my coordinate point. I know I want to point it towards the right. I know P is 1/4, so I have to go to the right 1/4, and that's my focus. I need to go to the left 1/4, and that's my directrix. So the focus, I'm taking the x and I'm subtracting a 4th from it. Actually, I'm adding the 4th because it's negative, adding the 4th. So it goes to the right, and it'd be negative 5 3/4. And then I'm subtracting 1/4 to get my directrix. So vertex, focus, directrix. So the good and the bad is that obviously the conics, it's still forcing the review on the conics, right? One, we have to go through the complete the square process to get it into that form, but then once it's in that form, I'm going back through everything we just did in 4.3. So your test is going to say find the standard form, and you're going to find that one first. That's the first part. And then if it's a parabola, find the vertex, the focus, the directrix. If it's a ellipse, find the center, the foci, and then draw it. And if it's a hyperbola, draw the center, the vertices, and the foci, and the asymptotes. One. You just don't know what you're going to get. So you could get an ellipse, you could get a hyperbola, you could get a parabola. Yep. And the homework's 2, I think it's 2 of each. Mm-hmm. All right, x squared plus 4y squared plus 6x minus 8y plus 9. So already you know it's not a what? Parabola, because there's 2 squared terms, okay? I can't determine if it's a positive in between or a negative until I get it into standard form, which tells you, like, if it's x squared plus y squared, obviously it's an ellipse. If it's x squared minus y squared, it's a hyperbola. But you can't do that looking at it yet because we're going to add and subtract things from this. So there's a possibility that when I add and subtract whatever number's on the other side of the equal sign, I'm going to have to divide by a negative, and then it flips. So you don't want to determine that yet, okay? What I do know is I have to group them. So I'm going to group together the x squared and the 6x. I'm going to leave this space because I want to fill that one in. And then I'm going to group together the y. So 4y squared minus 8y. Leave that space. And then I'm going to bump the 9 to the other side. Now there's nothing on the front of the x squared, so I don't have to do anything with that, but there is something on the front of the y squared this time. So I have to take that out. So the x stays as it is for now. The y, I have to take out a positive 4. When I take it off the first term, it also has to come off the second term, so this becomes negative 2y. So whatever you take off the squared term has to come off that b term too. Good morning, Giovanni. Can you put your camera on for me, please? Thank you. I'm going to try to catch the attendance. See how fast Miss Pierce is doing it this morning. Okay. All right, so now I got to complete the square of the red, right? So what do I add to that space? 6 divided by 2 squared becomes 9. I'm going to add that here. I also have to add it to the other side of the equal sign. And then I got to fill in the one with the blue, right? So 2 divided by 2 is 1. 1 squared is 1. I add the 1 here, and normally, again, I add the 1 to the right. But I have to take into account that I took something out this time. So you have to multiply that 4 times the 1. And that means I'm actually adding 4 instead of 1. Now I've got 2 perfect square trinomials to factor. So for the first one, I square root the x squared. I square root the 9. Take the sign from the 6. Put it in parentheses and square it. Second one, 4 is still there on the front. Square root the first term. Square root the last term. Take the sign from the middle. Put it in the parentheses and square it. Equals 9 minus 9 cancels out, but the 4 stays. With me so far? Okay, remember it's got to be equal to 1, right? So I have to divide everything by 4. So I get x plus 3 squared over 4 plus y minus 1 squared. It would be over 1. You can put it there. You don't have to. Equals 1. There's my standard form. What conic is this? An ellipse, which means I need the center, vertices, and foci. What kind of ellipse? Horizontal, because the a squared is under the x, right? Remember, a is the bigger one with ellipses. So a squared is 4, which makes a 2. B squared is 1, which makes b 1. It's horizontal. Where's my center? Good. Negative 3, positive 1. So I can start to graph it. Negative 3, 1. There's my center. I go right and left because it's horizontal. I'm going right and left the 2, which is my A. And that makes my vertices negative 5, 1 and negative 1, 1. I go up and down the B, which is 1. And I can draw my ellipse. And then the last thing I have to find is C. And remember, with an ellipse, C squared equals A squared minus B squared. So C squared equals 4 minus 1. c squared equals 3, so c equals the square root of 3. We're going to say that's like a 1.8, 1.7, 1.8. We're going to approximate it to draw it. And then we're adding and subtracting that from the x coordinate of my center to get the exact coordinate points of the foci. So -3 plus and minus square root 3, 1. Mm-hmm. So let's just pause first and see if we're on the right track before you get all the way in there. So I grouped together the 4x squared and the 8x together. There was only a y squared term. There wasn't a y term. If there was a y, obviously I'd group it with that y squared. But there's only a y, which means I don't have to complete the square twice. I only have to complete it for the x. So I take out the 4, and I get 4 in the front of the parentheses, x squared plus 2x, and then leave that space. Bump the 16 to the other side so it becomes -16. Then I take this 2, divide it by 2, that's 1, square it, it's 1. That's what I have to add inside the parentheses. Wait for it. Inside the parentheses, and then normally I would add it over here, but I multiplied it times the 4 that was on the front that I took out first, and that becomes adding 4. So then I got 4, square root the x squared, square root the 1, take the sign from the middle, minus the 3y squared equals -12. And this is why you can't say from the beginning, oh, the y is negative. This means this is an x squared minus a y squared, which means that it's horizontal. Because something like this could happen. So on the other side of that equal sign is not a 1, it's a -12. So I have to divide everything by -12. So both of the x and the y terms, their groupings, are going to get divided by -12. And what happens here is whichever one is positive now changes to negative, and the one that was negative changes to positive. So does that make sense? That's why I say wait until it's in standard form to determine what kind of conic you're looking at. So then this becomes an x plus 1 squared. It would be over -3. And this becomes a positive y squared over 4 equals 1. So to put this in standard form, this negative on the bottom here actually should go out front. And I should be doing y squared over 4 minus x plus 1 squared over 3.
Could you go back up first?
Mm-hmm. So you want to wait until it's equal to 1 to determine, usually you could tell if it's a hyperbola or an ellipse from the beginning, but you want to wait until it's equal to 1 to determine if it's horizontal, if it's vertical, that kind of stuff. So here's my standard form. It is a hyperbola. What kind of hyperbola? Vertical or horizontal? Vertical, because the y comes first. So if it's a hyperbola, I need a center, I need the vertices, and I need the asymptotes. My center would be -1, 0, opposite of what follows x, opposite of what follows y. My a squared is always first this time, so a squared is 4, which means a is 2. B squared is 3, which means b is the square root of 3. So I'm going to plot my center, negative 1, 0. Because it's vertical, I would go up and down the 2. And those are my vertices. So the x doesn't change, but the y goes up 2 and down 2. The b would be right and left root 3. So again, we can approximate this to be like a 1.7, 1.8 kind of a thing. So I just want to plot it so that I could draw the little box. So that I could find my corners. So that I could draw my asymptotes. And then the branches are vertical. It's vertical, so it's y equals k plus and minus a over b x minus h. Remember, it's b over a if it's horizontal, it's a over b if it's vertical. So I get y equals, my k is 0, so I actually don't need the number there. Plus or minus a, which is 2, over root 3, x minus h, x minus a negative 1 becomes x plus 1. And then lucky us, we got a square root in the denominator. I can't stay there, so we rationalize. 2 root 3 over 3 x plus 1.
I rationalize it again.
Why did I?
Like how I forgot.
Oh, multiply, so it's 2 root 3. You want to multiply both the top and the bottom by the square root of 3. And you will see, like, when you get to the homework, obviously you got to put it to standard form. That part's not part of your answer, like it doesn't ask for the equation, but it is going to then ask for the center. It'll ask for the focus, the direction, so we still have to find the focus, but it will ask them, and like next to it, it says smaller x, larger x, smaller, like that. So make sure you pay attention so that you're not getting frustrated at the marking it wrong because it's in a different order. So just make sure you pay attention to that stuff. So now the last thing I have to find here is c, and this time, because it's a hyperbola, c squared equals a squared plus b squared. So c squared would equal 4 plus 3, c squared would equal 7. And c is the square root of 7. So if I was to approximate that, that'd be like a 2.8 in between 2 and 3. So it'd be like here and here, which is changing the y. So my x stays negative 1. The 0 gets plus or minus root 7. So to simplify that, I could just write plus or minus root 7. And the homework will say give the smaller one, so it would be negative 1 minus root 7. And then give the larger one negative 1 and positive root 7. All right, so I grouped together the x squared and the 10x. It is a negative x squared this time, so that negative stays on it in the beginning. But then leave that space. I bumped the y and the 21 to the other side. So the y became negative, the 21 was negative, so it became positive. Then I have to take the negative off the x squared. So I take the negative out of the x squared. It also changes the sign on the 10, so it becomes negative or minus 10x. And then I want to complete that square. So 10 divided by 2 is 5. 5 squared is 25. I add it inside the parentheses. And again, normally add it to the other side of the parentheses. But because I took that -1 off, I have to multiply it by -1 first, which means instead of adding, we're actually subtracting 25. So then I square root the first term, so the negative's on the front. Square root the first term, it's x. Square root the last term, it's 5. Take the sign from the middle, put it in the parentheses, square it. And I get equals -y minus 4. You with me so far? Yep.
When I did it, I moved the negative x squared and 10x to the other side.
That's okay. Because I'm not done. Because I have to do what? There can be nothing on the x squared. So how do I get rid of that negative? Divide or multiply everything by -1. So it's literally going to change all the signs. And then that's probably what you have, right? No.
No, that's why I was confused.
So you moved the x and then the y stayed on the left?
Yeah.
So you have y minus 21 equals x squared minus 10x. That was the first step.
Yeah, plus 25.
And then plus 25 and plus 25.
Oh, I didn't add it.
Okay. Then it should be the same.
Yeah.
All right, so then this is a parabola, right? I'm going to group together the y and the 4. So this is a parabola that it's an x squared with a positive 4p. This means this is a vertical parabola. It's going to point up. My vertex is at 5, -4. The 4p, again, is a 1. So p is 1/4. I'm going to go up 1/4 to find my focus. Down 1/4 to find my directrix. So the focus, now the x stays the same. The y, I'm going to add the 1/4. So it's -3 and 3/4. And then the directrix, I'm going to subtract 1/4. So it's y equals -4 and 1/4. You good? Yeah, okay. So 5 and -4. Up 1/4 is the focus. Down 1/4 is the directrix. And my parabola should look like that. All right, so this time I moved the y squared because it was negative. I moved the y squared and the y to the other side, which made it positive, kind of like what Sophia had done the last time, right? Because it doesn't matter which ones I move. I just want to make sure that they're on separate sides. Now, normally my squared term's on the left, so I could take my answer at the bottom and rewrite it, okay? But I'm not done yet. That y squared can't have anything on the front of it, right? So if I'm multiplying by 2, how could I get rid of it? Divide by 2 or multiply by 1/2, right? Now here's the catchy part. I don't want to do that. So like if I did this, if I divide by 2, I don't want to divide both of these by 2 because now I have to then take it back out to get my parentheses. If you think about what standard form looks like, it would be x minus h equals 2. Actually, it would be 4p y minus k squared. This would be squared. This is what it normally would look like, right? So I'm kind of close on this part, except that I can't have anything in front of my squared term. So this case actually would be the y minus k squared. Oh, x minus h. So I have to get rid of that too. But like I said, I don't want to divide both the x and the 1 by it. I want to actually do like multiply by 1/2 and put it on the front of this parentheses. So it would end up with 1/2 x plus 1 equals y plus 5 squared. And again, if you want to rewrite it to the squared terms on the left-hand side, that's fine. But you don't want this distributed in. Standard form says that whatever's next to that 4p can't have anything on it either. So neither the squared term nor the x term can have something inside the parentheses on that. Yep.
You turn the 20y into a 10.
The 20y into a 10. I took the 2 out. So from here?
Oh, yeah.
Yeah, you got to take that 2 off. So now this is a parabola. So here's my standard form. Oops, not here. It's a parabola. The y is squared at positive 4p, which means it's facing to the right. My vertex is -1, -5. My 4p is 1/2. If I divide by 4 and multiply by a fourth, that means that p is 1/8. So my -1, -5, which is here, is my vertex. I'd have to go to the right 1/8 to get the focus, left 1/8 to get the directrix. So add the 1/8 on to the x coordinate of my vertex, and I get -7/8, -5. Subtract the 1/8 from the x coordinate of my vertex, and I get the directrix, x equals -1 and 7/8 and -5. Or sorry, not just -1, 7/8. So I opened the Webassign homework. There's 6 questions on it, because the complete the square obviously takes some time. There's 2 of each one. So what I want you to do is start it tonight, see what you can get through tonight. It's not actually due until Wednesday, because we'll do some extra practice tomorrow. So if you get stuck on a question, don't get frustrated. Just wait, come back tomorrow. We'll go over it. We'll do some extra practice, and then you'll be good to go for Wednesday. All right?